live. So, what am I doing today? A couple things. The first is I wanted to play with Cursor. I've heard a lot about it. Everyone loves it. I haven't used it yet. I'm used to VS Code. That's what I use at work. So naturally, that's kind of what I've been using with my hobby projects. But I wanted to try out Cursor. I know it's built on VS Code, but it seems to have its own thing going on with the LLM Copilot thing. And I had a project idea today. So I downloaded Cursor, installed it, and I decided to just start from scratch this idea that I've had brewing in my head a little bit. And I just wanted to describe what the idea was and have the new Claude Sonnet 3.7 take a stab at just generating everything. And I figured there'd be some tweaks and so on. And the TLDR is that it worked. I have like a basic thing running, and I haven't even gone through the code yet to really understand it. That's part of what I'm going to do in this live stream. But I first want to just step you through what my prompt was, what code it generated, and show you that it works, and talk about the project a little bit. So that should not take that much time, but just to show you the kind of capabilities of Cursor, of Claude Sonnet 3.7, and like just the state of things right now. You know, we're at the beginning of March 2025. What can these things do? Cool. So feel free to chime in on the chat. Talk about your experience. If you have questions of how to do something, please let me know. But, you know, I'm learning this as I go too. Like I said, I'm new to Cursor. Okay. So what project do I have in mind? I think the easiest thing to do would be to just show you the prompt, because that kind of explains the idea. Let me pull this up. Let's see if I can zoom in a bit. Can I... Control plus equals? Okay, that didn't work. Oh, wait. Yeah, it did. Okay. Sorry, I'm trying to make this so that you can actually read it. But I'll just say it out loud. I would like to create a simple simulation environment where I can use an LLM to translate goals in human language into instructions for a drone swarm. I want you to help create the initial code skeleton to get things running. Okay, so let me unpack that a little bit. I've played around a little bit on this channel with swarm intelligence, algorithms, and so on. And what's interesting about them is if you configure them in such a way and you have a particular problem, you turn them loose and they solve it in a kind of reliable way. Each agent is making their own decisions with local information. There's no centralized control and so on and so forth. But if you take that same swarm and then you throw a totally different problem at it, it's not like it can just adapt to that other thing. And maybe there's research along those lines. I don't know. But typically the algorithms are sort of purpose-built for the task. And I'm thinking, well, that's not all that useful. If you have like a swarm of robots and you want them to do cool things, it would be nice if they could handle multiple tasks, right? So then I thought, well, okay, maybe you have like a toolbox of algorithms that, you know, I need to move the swarm from where they are to point A on average, right? So like not everyone can go to the exact same point in space, so they would have to move as a group, not run into each other, avoid obstacles, so on and so forth. But you could imagine that as like a routine. And then maybe you have like a forage for food or find hikers in a forest. I don't know what the various tasks could be, but you can imagine certain primitives that they had access to. And one of the challenges of controlling swarms is that it's hard to express the goal. And I thought, well, hey, maybe an LLM could help us basically interpret the human goal, where I just say what I want. And then if it understands the primitives and the routines that the drones have access to, maybe it could come up with the plan of like, first do this, then do that. First travel to this point, then run your search algorithm. And if you find something, then communicate this back, so on and so forth. So that's kind of the idea, is have this LLM as this cognitive layer between the human and the drone swarm to create an instruction set for each of the drones. And then once the drones get the instructions, they run off autonomously. So they don't have to rely on the LLM to make every decision, first do this, then do that. They more just get the plan from the LLM, and then they go out and they solve the tasks. So that is the idea at a high level. And that's what I wanted this to do from scratch. So I start specifying some requirements. I would like to start with a simple Pygame grid environment with multiple drone objects. Those drones should be able to follow primitive actions like moving to adjacent grid spaces, wait, etc. There should also be an abstraction that can chain together these primitive actions into more complex behaviors, like explore, move to point, etc. Drones should be able to run these little algorithms. So I'm making a distinction here between essentially the actions available to the drone, move left, move right, move up, and higher level algorithms of, say, like move to this destination point, right? You might have to chain together multiple commands to do that. Or you could even have higher level ones like explore your local area. Maybe there's like a random walk of movements, something like that. So I tell Cursor, I'm not quite sure how to basically organize the code. I don't know what the right abstractions are. Between the drone objects themselves, the primitive actions, the more complex algorithms that choose the sequence of actions. So please make a strong design choice that can help scale to more complex behaviors later. And then I say, finally, there should be an LLM object that interprets goals in natural language and turns that into instructions for the drones, combining these primitives or algorithms into a plan. The drone should have an ability to take these instructions and execute them. This is a key capability of the drones. The LLM should either generate code or instructions/parameters in JSON format that could be interpreted and turned into action plans. So that's sort of the output I'm expecting of the LLM. You tell it the goal, maybe you also contextualize it with what the environment is, how many drones you have, and so on and so forth. And then it generates some sort of output that the drones can understand, whether that's a JSON object or actual code that is going to run. I'm not totally sure or care to make a decision at this point. A last requirement. Final requirement is that I want the LLM to be able to define hooks on event triggers from the environment. For example, if a drone triggers a target detected event, the LLM should be able to specify a callback function that tells the drone to, for example, report back the location of the object and then await further instructions. So I want there to be essentially events that trigger actions. and then allow for another round of communication. So if a drone finds something, it should tell the LLM, hey, I found this thing, now what? Unless it already has a plan for what to do, of course. But I at least want the capabilities for these types of events to exist. So let me pause there. Let me know if you have any questions. But again, the idea, let Cursor and Claude Sonnet 3.7 generate this entire program from scratch. I have no experience with Pygame, and I don't, as you can tell from the prompt, have exact ideas of how this should be implemented, or even some pretty major decisions about the communication interface and so on. So I'm leaving a lot up to the model here. Okay, so let's see the output. I don't want to go through all the thinking because that can be quite long, but basically it comes up with a file structure, it kind of understands it. It is worth going through this. So it understands my environment. None of these files previously existed. It is suggesting all of these. So when I wrote that prompt, I had 0 files in my folder here. And it is suggesting that I create this 6 files. And then for each file, it gave the implementation. And there was a little button here that basically said, create that file, or I forget the text on the button, but that was the effect. So I clicked that button, and then it created this environment.py file that had all of this content in it. So it created environment, created drone. I just went through here and blindly accepted. I did not read the code in any depth, other than just having some curiosity. You see there's a separate behavior.py. There's the event system that handles the callbacks, and there's the LLM controller, and a main.py that ties it all together. And then it gives a design explanation. I don't even think I actually read this part, but maybe we will in a few minutes. So that's cool. Then I wanted to actually run it, right? I want to see, does this thing work before I bother reading everything? And I realized I didn't know how to do it. And then I realized, well, I don't even have like a particular example or an LLM wired up here. Like, so I said, okay, how about we just have a mock LLM call that, so right now it's a dummy, and it will just generate a simple set of drone instructions that are static, that essentially initialize to a random point and then move to a random point. So I'm pretending that I have an LLM at this stage just to test the rest of the code, and the output of the LLM I'm hard coding, and it'll essentially generate a random position, starting position for each drone, and then tell it to move to a random position. So I ask it to modify the code to enable this, and then tell me the command line argument to run to make this happen. So again, it generates this thinking trace, which I ignore. And then it says, okay, let's update this LLM controller file. So I clicked the apply button and it automatically updated the file. It also updated the main.py to essentially allow for this mocking capability. So you see here, if I pass in through the command line this mock argument, then it'll create these random positions. And then it tells me to run the simulation, I just do this. Or I can actually specify the number of drones, the targets, and so on. I ended up getting, it worked, but I got some kind of error that I didn't understand. I pasted it in. It said it understood what the problem was, and it generated a fix. I clicked accept, and sure enough, the error went away. So I'm well aware of the fact that it's odd to be working with a code base that you've created but have very little understanding of. But hey, that is part of vibe coding, right? And it actually explains it. But, if I don't understand how it worked in the first place, I don't care that much about why it broke or what the fix is. And then I started asking it questions about, okay, how do I integrate this more closely with my code editor here so that I can just run things? That's not worth going into here, I don't think. But let me just run it for you and show. All right, this is it. So what you'll notice, there are 3 targets here in red, and there are 5 drones. You can see that I passed in as arguments, now first of all, mock, which means it'll do the random thing, not use the LLM. It passes in number of drones is 5, number of targets is 3, and then the width and height of my grid. I didn't even ask for this, but it actually labels each of the nodes, which is very cool. So it works right out of the gate, right? Like I don't know how it works, but it actually works. That's super cool. I'll run it one more time just so you can kind of see what's going on. One thing I noticed is there's no collisions. Also, instead of going diagonally to the point, it seems to go like all the way horizontal and then all the way vertical, or vice versa. I don't know why it does that. I'm sure it's part of the code and we can fix it. So yeah, right out of the gate, I think it's a very good starting point to test this idea. So other than just show you what the goal was, the fact that this generated the whole project by itself and there was one minor bug that it fixed, it works. So I wanted to show all that. The next thing I wanted to do was try to understand this code a little bit, and I think that will involve asking questions to Cursor and Copilot, whatever you want to call it, the chat function. So you can ask a question to your code base, right? So for example, you can highlight this and add to chat and then start asking questions. I can show one example of that actually. But the other thing I thought I would do is try to implement something a little bit more complex that's showing the behavior that I want. So I thought it would be cool if once the game is running, again, I'll just pull this up, if we have a text box somewhere where I can essentially type in an instruction. And the type of thing I'm thinking of is something like move drone 4 up 5 and to the left 3 spots, or something like that. And when I issue that command, that there's this interpretive layer that basically turns that into an instruction set, sends it to the drone, and has it do that instruction set. I don't necessarily want to get an LLM actually involved in this very simple case. I'm more interested in building this kind of interaction piece with this application. So I think I'll probably just do something simple like a regular expression extraction on my text string or something like that to turn the text string into instructions. But hopefully it's obvious that an LLM would clearly be capable of converting that sort of thing into the structure if it knows the structure of the API to talk to the drones. So that's my goal. I think I'm debating in real time here whether I just tackle the goal or I try to spend some time understanding the code base. And I'm leaning towards just trying to tackle the goal because I think an understanding of the code base will sort of come from trying to figure out how to change. So let's just go ahead and do that. I'm going to start a new chat. I'll just type in what I want to do. I would like to add a text interface to the game so that I can type in an instruction, and that instruction is then parsed and transformed to an instruction set for the drones. Hey Hydro, I don't know when you joined, but let me know if you want to know what the hell's going on. Let's see here. What is this? Man, I just got done explaining. I'm kidding. Yeah, so what this is, I'm trying to get an LLM to take instructions in human language and turn that into a plan via code or something that it ships to drones, which could then execute that code autonomously. So right now I have a dummy environment that was totally created from scratch with Cursor. I just told it what I wanted to do, and it wrote all of the code in all of these files. I haven't written a single line of code. You can see here it's now created 5 drones and 3 targets, and I told it to start, just put them in random positions and tell them to move to random positions. And now I'm starting to add the next incremental piece of complexity here, which is I want to be able to interactively say, move this drone here, and get it to interface with this, have this LLM intermediary. But longer term, I want to be able to say things like, search this environment for lost hikers, and if you find one, deploy a drone with a health kit to their location or something like that. So then basically the LLM would tell each of the drones, like, hey, you go here, you go here, you go here, and run your search algorithm. And let me know if you find something. And then the drones would autonomously go out, execute those instructions, and then if they find something, they report back. And then the LLM would be like, okay, now I'm going to deploy this other drone to that location and give this thing, whatever the case may be. The point is, you have this LLM as a translator between the human specified goal and the instruction set of the drones. And in that way, we can control the swarm and get them to solve novel tasks. That's the overall goal. But we're far away from that. So far, we have that game. But again, all of this code has been generated by Claude Sonnet. Yes, the Zerg. Okay, so I would like to add a text interface so that I can type in the instruction, and that instruction is then parsed and transformed into an instruction set for the drones. Okay. So my prompt here, I would like to add a text interface so that I can type in an instruction, and that instruction is then parsed and transformed into an instruction set for the drones. Command and that. Command is then parsed and transformed into an instruction set for the drones. For example, if I write move drone 1 up equals 3 and to the left equals 4, this should be converted into movement commands. For drone 1. I will eventually use an LLM for this translation, but for now, let's have the mock LLM use regex to extract the drone ID and movement commands, and then return the appropriate commands to the drones. Okay. So I think if I just hit enter here, it will just ask Claude Sonnet that question, but without any context. I can add particular files here that it can read, or I can click this code base button, and you will see what happens. So it's reading all of these files. It's searching them and finding the relevant stuff. I don't know exactly how that works. Presumably it's using some combination, basically a RAG system, something like that. Okay. I'm not going to read the thinking stuff. I'm just going to check out the output. I'll implement a text interface that allows you to type commands. Okay. So adding a text input field to the UI, creating a command parser using regex, connecting the parser to the drone control system. Okay, so first let's modify the environment.py file to add a text input area. Okay, so let's check out this diff. I really like that it makes this into like a get diff. Oh, okay, so it's modifying extra height. Great. Again, I know nothing about Pygame. It looks like it's handling input events. I don't know what collide point, whatever. Okay, drawing the input area, input text. Okay, self.process input events. Okay, that's this new method here. All right. I don't really understand all that, but I'm going to accept it, see what happens. That's how this whole project has been created. Okay. So we did that. Now let's create a command processor in a new file called command processor. Okay. So this is how the new files were created. It pops down here. It's suggesting I use command processor.py, which you'll note does not exist in my repository. Whoops. So it created that file and added all of this code. I'm going to accept. Finally, let's update main.py to use our new command processor. Okay, let's apply that. Blindly accept. Okay, let's see if it works. Type command here. Wow, it's very hard to move drone 1. We'll just say right equals 4. Press enter. Okay. Hey, look at that. It worked. Move, I don't know, drone 4 up equals 2 and right equals 6. And now I know what happens when a target and a drone are in the same place. Okay. Wow, so that worked. You think some kind of atomic instruction is required, like CRUD and backend, and just combining them. Defining abstract unit behaviors to avoid LLM depending concrete packages like Pygame. I don't know that I totally understand what your point is. But yes, there is a notion of two different types of behavior. One is like a primitive action. So our primitives are move action, wait action, scan action. And then our behaviors chain together these primitives. So right now we have like a move to waypoint, right? Obviously, if you're moving up, let's say 3 points, then your action is move up, move up, move up. And we can chain together. And the idea that I have longer term, if I keep playing with this, is that you'll have essentially a toolbox of things you can do. Some of them are simple, like move from A to B. Others are like search an area. And that's where, for example, the swarm algorithms for searching and obstacle avoidance and so on can come into play. Because like we know how to implement that stuff. And you don't need the LLM to say, all right, drone 1 move to this point, and then drone 2 move here, and then drone 1 move there, and then drone 2 move here. Like that would be too much. That would be having a central control brain. And then you have to worry about like the inference speed and all that stuff. I don't want to do that. I want the LLM to come up with kind of the master plan, that how to combine the core capabilities into the plan. And then the autonomous agents go off and do the actual stuff using their toolbox. They already exist. Yeah, sorry, I'm not following what you're talking about. I don't know what they is referring to here. But hopefully my intentions are clear. Okay, well, I thought that would take a little bit longer, but it was like a one-try thing, and it just worked. The next thing I would want to do is actually get an LLM as an interface. But maybe first, I can set up my environment better. So right now I have targets and I have drones. I suppose the last thing I need is some kind of reward. Yeah, maybe I can ask it to keep track of how many items are found and then implement some kind of random walk search algorithm for each of the drones. So let me start a new chat. Okay. I want to, let's see. What is this environment called that we already have? System. No. Okay, maybe it's main that I want to modify. see here. So I want to create a search task where drones are looking for targets and have the goal of finding all targets on a grid. For now, I want each drone to take a Okay, so I'm saying I want each to be able to do a random walk. There. And then trigger a found target event if a target comes into their field of view. The field of view should be configurable, but be a square of surrounding grid spaces around the drone. And the found target event is triggered. It should notify the LLM object a callback specified by the LLM to await further instructions, and the LLM will then send a new command to continue its search. All right, we'll try this. Yes, I've done a lot of GNN explanations over the years. I see you mention RL. Yeah, I think there's an opportunity to use RL at some point, but I'm trying to not use it anytime soon. Oh, good to hear, man. Glad you got something out of it. Okay, let's see what it came up with. Oh, wait a second. I don't think I gave it my code base. Okay. I'm going to have to redo that. So what happened is it just generated all brand new code and ignored what I had, and that's because I didn't tell it to use my code base. Man, this is amazing. I just hope nothing breaks. Creating a search behavior class. Okay. So what behaviors do we have so far? Patrol. Oh, interesting. Haven't used that. Explore. So why is this different than explore? All right, I'm going to have it modify that. Because it's moving and then scanning. But I think if it moves into a place where it's close, if it's within the field of view, then it shouldn't have to do a scan. So I'll tell it to fix that. Okay. Was it just adding? Okay. Apply. Yes. All right. If mock. Okay. Sure. There's so much I don't understand. Okay. So I basically want to tell it I don't want it to make scan separate from move. So in search behavior, it seems that moving and scanning are separate, but I don't want a separate scan operation. I just want the drone to have a detector which triggers when a target is within the field of view. A detector might need to be a separate object attached to a drone. And perhaps instead of creating the new search behavior class, and instead modify explore behavior. Such that target detected if there's an attached detector and it returns true. All right, we'll see what happens. So I'm telling it I don't want a new class. I want it to modify this one. And then I was thinking you'd probably want detectors as separate objects, because in this case, I have a very simple detector that's going to look at the radius, but I might replace that with some other type of detector that's maybe directional or something like that, or LiDAR. I don't know. There's lots of possible detectors out there. And I don't necessarily want the logic of my search behavior to be dependent on any of the details of the detector. It should just be able to abstract that out. So let's see what it comes up with. Okay. Let's add a detector class to drone.py. All right, let's do that. Let's add a detector property to the drone class. Okay. Let's modify the explore behavior to make it suitable for search operations. Okay. Now, I'm very curious if it'll be smart enough to remove that other class. Because one experience I've had is it's very good at generating code, but it's not very good at telling you to delete code. Okay. I have no idea what that's doing. Detection happens automatically during every update cycle of the drone. Okay. We're using a new setup code section. Okay. Okay. What is this setup code? I'm curious about this. Oh, this is kind of a mess. It's like writing code. Ugh, that's kind of gross. All right, I'm going to change that. I don't like that the LLM is creating the drones. The drones... Okay. Okay. All right. Let's see what this does. Alright, I see a lot of red, which is good. That means it's deleting. All right, let's see what happens. Detector is not defined. Okay. I won't bother the giant model for that one. LLM would normally generate commands for the drones here. Drones are already configured for searching and will explore automatically. Okay. So I think what's happening is it's passing in the actual drone object here. And then it breaks the regular expression. All right, let's see if I don't know what composer is. I'm going to try it out. Let's see. How do I open this? Okay. Command processor. Try to extract drone ID. Oh. This is the regex part. Okay. I don't actually understand this. Let's see. That's a really stupid way of doing it. You loop through a number, which happens to be 10. So if you have 11 drones and you type in drone 11, it wouldn't work. That's pretty terrible. That's okay, because this is just play anyway, right? Once we have the LLM, we don't need to do all this regular expression stuff. This is just a test. I don't understand this target position. I'm not so sure about this. Yeah. All right. I don't know. Let's see what happens. Okay. I'm going to do a full code base search, Claude 3.7. Let's see what it gets. Okay, let's try again. All right, this is like the third try with kind of the same problems. Oh, I see the issue now. Okay. Wait, what happened? Oh no. I think it just deleted a bunch of my code. Do we really have to do this with LLM agents? I don't really know what you mean. Like, this is a very simple example to just get something that runs with the idea that we'll do something more complex later. So let me give you an example. If we were just doing like a search problem, and we knew that we were doing a search problem, then we could take some off-the-shelf swarm algorithm and like just unleash the drones, and they would do their thing. They communicate with each other. They do like the optimal distance so that they cover ground efficiently and all that stuff. If you then want them to solve a totally different problem, like use half the drones for search and half the drones to wait until something is identified, and then you go send a drone to drop a package off, a care package to them or something, like that's going to require a very different set of programs. And what I want to do here is basically use the LLM as the interface between when I say what I want to happen and the instruction set that gets written. So, for example, I should be able to say, search for all the targets in this environment, and then it sends them off on their merry way. I should also be able to say, search for the environment, or take half of them to search, and when a target is identified, use the other half to send them care packages. And then the LLM would just handle it. Another thing I could do, assuming I gave the drones vision, is I could be like, look for red boxes, but not green boxes. And what could happen is the LLM does a search thing and asks for an image back, right? And then the model is smart enough to know, is this a red box or a green box? And then it tells the drone to either keep going or to mark that as a target. So like by having this smarter layer in between, I think you can generalize a lot of the problems and offload it to that smart thing, which knows how to stitch together the core capabilities of the drones, which themselves are not that smart. That's the idea anyway. I came up with this today, so it's like a little half-baked. Okay, so the last thing I want to fix before wrapping this up is, first of all, I'm concerned that it deleted a bunch of my code, and since I didn't take any time to actually read or understand the code, I don't know. But also, my thing instantly disappears. Okay. The error is gone, but the window instantly disappears before I can see anything. I'm also concerned some code was removed because I see existing code. So please create the game so that the drones are given the command to explore. And log to the terminal when, what did we call these events? Oh. Event system. We had these like target found events or something like that. Maybe that will be in the detector. Drone detector. Okay. Target detected. All right, let's try that. Crew AI. I don't know what that means. Wow, this is doing a lot of work. Is it because it deleted a bunch of my code? Okay, let's see what it had to say. Okay, it did delete my code. Okay. Make sure your entity class has a method for updating and rendering. If it doesn't, you'll need to add these methods. Entity. Okay. Shouldn't it know? I mean, that base class doesn't, but my drone class should have update and render. Okay. I'm going to skip that. All right, we'll see what happens. It totally changed the look of it. It is logging. Okay. move drone 4, I don't know, up equals 5. All right, it worked. So let me summarize what's happening. At the very beginning of the program, the LLM told the drones to go explore. And part of the event handling is that if a drone's detector detects a target, it sends an event that says, hey, I detected a target. And right now we just log that back to screen. But in the future, we will handle that by reevaluating with the LLM, say, hey, a target was found here. What do you want to do? And it will have, of course, the context of the environment and the original goal and all that to send new instructions. So in the case of like a search and rescue, then the follow-up instruction might be, come back here to get a rescue package, drop it off at this point, and then tell me when you're done for next instructions, something like that. So all of those things are happening. We're getting the events. The drones are off executing their autonomous algorithm. Plus, we have the ability to specify a command in human language, in natural language, like move drone 5 left equals 10, and it overrides the behavior with a new behavior, which in this case is very simple. But it shows that we can express our intent in natural language, and that can translate into a message, a new instruction set for the drone. So now once we get an actual LLM that understands the toolbox of the drones and the commands that I issue, I should be able to do much more complicated things. And that will be for next time. So to be clear, these drones are not LLMs. There's a single LLM that's basically the planner. And at the beginning of the process, gives an instruction set to the drones, and then they autonomously go execute those instructions, with the possibility that there are certain events that trigger a reevaluation at the LLM level. Yeah, so the real goal here is to use the LLM to talk to the swarm, and not in a centralized control way of dictating its every move, but telling it the plan at a high level. And the plan can only be executed using tools from the drone's toolbox. So it has a search algorithm. It has a ability to detect by scanning an image. It has the ability to detect other drones around it. Whatever capabilities we give it, those are the tools in its toolbox. And then the LLM will piece those together into plans to solve problems we specify in natural language. Anyway, this also, just as much as it is about the project that I'm doing here, it's also an experiment on using Cursor. And this idea of vibe coding, right? Of like just saying in natural language what I want to happen and seeing if, in this case, Claude Sonnet 3.7 thinking is able to basically generate all of the code and fix all of the problems. And so far, the answer has been yes. Although it totally deleted the code for the game once, the rendering code, and then had to recreate it. Now it looks totally different than it did. But aside from that, it's been pretty seamless. So I'm super impressed. And I think the next step will be for me to actually figure out what the hell this code is doing better than I understand it now. And then wire up the LLM and delete all the code that's using like regular expressions and stuff as a test. So hopefully this has been interesting. I don't know. It's kind of a random idea. Yeah, I'll see you guys around. Thanks for joining.